Ready, Mishra?
Sir, we are live now. We can start.
Okay. Thank you. So, good evening, all. Namaskar, and welcome to this GMRT Online Science Day International Event 2026. As it's rightly been said that it is an international event since last couple of years, we have been getting the projects and participation from countries outside India. Of course, it is a nationwide, the largest event so far. And since COVID, when we thought that we can reach out to schools, colleges, and give them the platform for participating in a national level science exhibition event. So with the help of Indian Institute of Knowledge with their mobile app Growing Dot, we started this, and this is our 5th year that this is online science day program is there. Last 25 years, GMRT has been actively involved in celebrating and organizing National Science Day on 20th Feb in a physical mode at our GMRT Observatory. And with that tremendous response, and because of COVID, we were stuck, but with this technology helped us, and we started having this event successfully in organization with NCRA and IIK efforts. So this year also we had done thing. Somewhat we delayed this time the inauguration of our online science day event because of some other issues. But now today is the day that we are celebrating. For this very good event that we have Professor Dipankar Bhattacharya, who has kindly agreed to be the chief guest, who is a Vice Chancellor of Indian Institute of Space Science and Technology in Thiruvananthapuram. Along with that, we do have Professor Yashwant Gupta, the Center Director of National Center for Radio Astrophysics, Professor Ishwar Chandra, Dean GMRT, as well as the Chairman of GMRT Online and Offline Science Day 2026 event, and Professor Divya Oberoi, the Chair of Science Outreach Committee and Faculty at NCRA. Along with this, we have now Mr. Sachin Nalapure from Indian Institute of Knowledge and Growing Dots, who is our associated partner for celebrating event. And there are many teachers who involved in our evaluation process, like Professor Kode, Professor Vani sir, Shilpa Bhagwatman, along with our NCRA colleagues here. So welcome you all, and without taking too much of time, we will start our this thing. So we will request Sachinji, because Nilesh Chadavelkar is right now he's traveling and is not reachable because of some very uncertain reason. But we will request Sachinji, you can just bring out the role of IIK in just for online science day of this year 2026. You are muted.
Thank you, sir. I'm Sachin Nalapure, representing here Indian Institute of Knowledge. Good evening, everyone. First of all, I would like to extend a very warm welcome to our chief guest, Honorable Professor Dipankar Banerjee, sir. Also to Honorable Professor Yashwant Gupta, sir. I also warmly welcome to all the students, teachers, parents, and evaluators who are attending this event online. As you all know, we are extremely glad and proud today. Last year, we had participation only from the UAE. However, this year we have expanded further and received participation from the UAE as well as USA and Singapore. What started as a national initiative has now truly become an international event. We have crossed continental boundaries and reached a global platform. This is a truly remarkable achievement for all of us. So thank you, everyone. I would like to put some light on the evaluation process. After the inauguration program, the evaluation process will begin in two ways. First is expert evaluation and second is public evaluation. In expert evaluation, a panel of 50 subject experts along with scientists from the GMRT will conduct the entire evaluation process. The best projects will be shortlisted. The shortlisted participants will be informed in advance. The second way is the public evaluation. This is also one of the innovative and the beautiful idea. The public evaluation is open to everyone. Any viewer can watch and rate these project videos. There are three special awards under this category. First one is most viewed project, second is most rated project, and third is most viewed project by a single person. So I would like to request all students, teachers to actively share their project video URLs with friends, groups, schools, so that we can reach the maximum number of people. About result and award ceremony, the result declaration and the award ceremony will take place in the first week of June. The exact dates will be announced in advance. The participants will receive notification via email or WhatsApp. Very important notice I want to declare here. The participation certificates can be downloaded from the Growing Dots platform starting from the 22nd March 26 using your login credentials. I am repeating here. Participation certificates can be downloaded from the Growing Dots platform starting from the 22nd March 26 using your login credentials. If anyone faces any difficulty, our helpline support is always available to assist you. Lastly, just I would like to comment one line here. We are truly honored to be part of this event associated with GMRT, which is the one of the world's most renowned scientific marvels. It is a matter of great pride to contribute to its science outreach movement to help develop a scientific approach among the students. Thank you everyone of the wishing all of the participants for all the very best. Thank you, sir.
Thank you, Sachinji. And that was a great thing from Indian Institute of Knowledge Growing Dots. Without your support, this event wouldn't have reached at that level. Just to give updates to all our members here and the chief guest, that we have received total projects 716 with the participants of 1,507. And international participation, there we have 23 projects coming from UAE, USA, and Singapore. There we have a group wise category. That means 5th to 7th standard we have 271 projects, 8 to 10 standard 255 projects, 11th 12th and ITI level 46 project, BSc and diploma level 47 projects, BE, ME and MSc 79 projects, and we have project received from teachers and lab assistant 28 project. Just for information of all. Now I request Professor Ishwar Chandra, the chair of Science Day Committee, to say a few words about this event.
Okay. Yeah, good afternoon to everyone. So it's a nice platform to discuss about science. Now, what I was thinking is that nowadays, because this is what I'm telling today came from a discussion during the Science Day along with one of the participants. What I understood is that many people take many things for granted. For example, this generation students, all the technology they use, all technology and scientific advances in their hand, whether it is transport, medical, or mobile gadget or the electricity in their home or anything they use, they don't think beyond that how it would have come, or if some other scientist would not have spent time on some effort, this discovery would not have come. So that way nobody thinks. So it is very important that we realize that every technology and scientific benefit which we use today has some history and some effort of some scientist, maybe 10 years ago, maybe 20 years ago, maybe 100 years ago, have spent time on it, whether it is camera on the mobile or GPS or anything but we use daily basis, has gone through some scientists' painful effort. So, and there are many more things to come. Some people think that, okay, now a lot of scientific advantage, scientific community and technology is so much advanced, now there is very little new things to be done. That is not true. There are many more new things to be done, which we can't even think beyond. Many things have come. 100 years ago, nobody would have thought about a GPS or mobile kind of situation, mobile kind of way you can communicate across the globe. So today that is possible. So today, if somebody thinks that some things are not possible, that is not also not correct. So the job of the students of next generation is actually think beyond the textbook and also think and out of curiosity and start making some innovations and I mean, it's basically develop a scientific attitude instead of just using and getting marks and getting a regular job. It is very important that people develop a scientific attitude and contribute towards progress of science. In another 50 years, we should see much more developed science environment for the humanity. So I will hand over the mic to Solanki for continuation.
So thank you, Professor Ishwar. That was rightly said, and that is the need that where the GMRT and has been in the field for many years, and we wanted to continue our efforts. Now the NCRA has been actively involved in many outreach activities and all these things, and Professor Divya Oberoi is now heading NCRA Outreach Committee. I will request Professor Divya Oberoi to enlighten about NCRA outreach activities and also how this GMRT Online Science Day also has been making a significance in this particular outreach. Professor Divya Oberoi.
So, yeah, thank you, Solanki sir, and once again a warm welcome to all the guests on the stage. So Professor Dipankar and all my colleagues from NCRA, all the students, their parents and teachers and evaluators who have joined us for this. Thank you so much for being here. You are the ones who really make all of this worthwhile. Yeah. So, Mr. Solanki or Dr. Solanki asked me to talk more about the NCRA Outreach Committee. What I want to really talk about is why should an institute like NCRA do outreach in the first place? So the reasons, there are many, right? Starting from, in fact, our own constitution. If you're, in our constitution, there is this 51AH, I don't know, section or subsection or whatever, which calls upon every citizen to develop scientific temper, humanism, and a spirit of inquiry and reform. Right. So that right there in the founding document of our nation is the onus on us to build our scientific temper. And we wanted to contribute towards that in a small way in our neighborhood, and now actually with increasing reach, especially as we are able to do it online. So that was a part of why we wanted to do it. There are other reasons like, okay, we are funded by taxpayers. It's our moral duty to share some of what we do with the society. More important than that for us was really the, as Professor Ishwar Chandra was just saying, we take a lot of things for granted. That's one aspect. The other aspect is that when we teach science in our schools and colleges, it's mostly taught in past tense. It's not taught as a process which is continuous and ongoing and self-correcting, right? It is all about something which was done by somebody a long time ago, somewhere far away. That is a narrative which we wanted to change, because science is a continuous process. As you learn more, you also realize more about what you still need to learn, the limits of your knowledge and the ignorance which lies beyond that. And in science, you learn, you make mistakes, and it's a self-correcting process. As you go further, you realize those mistakes and you correct them and keep doing that. And learning by doing is perhaps the most efficient way of doing something. And that is where, these projects come in, that all of you students, all of these 700 plus projects which have been submitted, all of these were a challenge for you to do something, to create something, to learn something, to try to solve a problem. And in the process of solving whatever problem you chose to solve, you encountered a few other things, a few other problems, a few other things which you needed to learn to achieve your objectives. That is really the path of science. You choose an objective, you choose a problem which you try to solve, and then you figure out whatever else is needed in the path of doing that. There's one more reason why it is very important for an institute like NCRA to do outreach effort. That is related to the facility which we run. NCRA runs the Giant Meter Wave Radio Telescope. It is the world's most sensitive radio telescope in most of its frequency range of operation, which is from 150 megahertz to 1450 megahertz. It is really the only astronomical facility of its stature in India. It is used by more than 4,000 scientists from more than 30 countries, and they have to compete for getting observing time on this. Right? There is no other facility in astronomy, in the whole of realm of astronomy, where people have to compete from the rest of the world to gain observing time on that. So we also wanted to break the narrative that good science and good facilities are all in the Western world, or at least somewhere far away. That we in India have a lot to catch up on. There are areas in India where we are the cutting edge, right? Where there is nobody better than us for that specific aspect of science. So that is again a narrative which we wanted to break and have role models which you can relate to, right? Students in our institutes who just a few years ago were students in schools and colleges, just like many of you in the audience. So it is a matter of what you do with the spark which gets ignited in you, the passion which you have, and that can open the doors for you to do cutting edge science right here in India, right? In terms of the activities we do, they are, we go to various schools and colleges to give lectures, we organize stargazing events, we organize visits to GMRT, we participate in the amateur astronomy associations in their programs. We recently co-organized a symposium along with the Astronomical Society of India and a few other collaborating institutes to bring together astronomy communicators from across the country. Right? So we work closely with the Astronomical Society of India in their science communication efforts as well. So these are the sorts of things we do, but what really motivates us to do this is the fact that if we can ignite that spark in some of you, not necessarily to become astronomers, but to develop a scientific temper and to adopt a scientific way of life as you go ahead. Because therein lies the solution to a lot of the problems which you are going to encounter as you go. Therein will lie your ability to distinguish between, all the fake and unreliable news which is forced upon you, distinguishing between that and the truth and the reality, and using your own judgment to arrive at right decisions for whatever course you want to take in life. So, yep. And this virtual science day has really been a boon for us because it allows us to go beyond the usual geographic boundaries which we had been operating in, right? So now not only states across India, so I don't have the number for this year, but last year we had more than 13 states and union territories across the country from where we had representation. This year we have a few international participants as well, which is great, right? And yeah, it's been very heartening to be a part of this effort. And with that, I'll stop. Thank you so much.
Thank you, Professor Divya. And I request Professor Yashwant Gupta, the Center Director in NCRA, on the welcome address on this occasion.
Yeah, good afternoon and a very warm welcome to all those who have joined us today for this virtual science day. It's really great to see and a special welcome to my old friend and colleague Dipankar Banerjee for gracing us on this occasion. It's really nice. I know he has a very busy schedule and he has made time for us. So that's fantastic. And what I would like to say is that the Science Day has been a very strong tradition at NCRA for a long time, almost 25 years since the time we built the GMRT and started operating it. And the reasons why it is important and has been a core element of our activities has already been touched upon by both Professor Divya Oberoi and Professor Ishwar Chandra. And there are various reasons that they both elucidated as to why this is of importance to us. So I will not dwell more on that, except to say that when we started, it was confined to the local region around the GMRT. So GMRT is spread out over 30-kilometer region, the antennas, and our initial target was that we should be able to attract schools in that area to come forward and display what they are doing in science, along with showing what we do at the GMRT. And from there, we've slowly grown over the years to the extent that if you go back to the previous recent years, we have in the in-person Science Day, which is celebrated on 28th February and the day after at GMRT, we have participants coming from faraway places like Mumbai, Nasik, Kolhapur, and even some participation from Nagpur and Bangalore and so on. And so the overall the GMRT Science Day has been a big success, the one that we hold in person, and so much so that we run it for 2 days. And it was growing year by year. And then COVID struck and everything came to a halt. And as we know, COVID changed our lifestyles in many ways, our way of thinking, our way of doing things. And so when we were confronted with this situation, that no in-person Science Day, we said, well, what is it that we can do? Maybe the next best thing. And that is when this idea came up, that in partnership with the Nilesh and the Indian Institute of Knowledge, to do something different, that do this in a virtual mode, whereby we can invite students from schools to make videos of their science projects, and we will provide the platform whereby they can be uploaded and can be made visible to the general public. And then we put together behind that a scheme for evaluating the proposals, the projects, judging them, and then awarding the best ones. And to be honest, I was not very sure how this is going to turn out when we started this, but we said, look, let's give it a try and see. And as we know that, COVID also taught us new things. And what we realized soon is that, science really knows no boundaries. So what we started finding is that this caught on very quickly with people in the country. And within the second year or so, we started getting projects being submitted from, as far as Punjab, Bengal, and so on. And then, in a moment of maybe semi-seriousness, I challenged Nileshji and Solanki that, look, we've now reached all parts of the country. Can we take this beyond the shores of India? And and that is they took that up, that challenge. And for the last 2 years, we've now started getting projects coming in from places abroad. And that again just reinforces this thing that science really knows no boundaries. And the enthusiasm for science, it's the same, whether it is in India or it is in the UAE or it is now in the US and other places. And I think that's a fantastic thing that we have learned, from COVID. That look, you should be able to think out of the box and try different things and then see how they work. And I'm really glad that this experiment has worked out so well. Of course, it has not been without its challenges. I mean, you can ask, well, that like I said, my initial worry was about the quality of the submissions that we would get. And so ensuring that the quality of the videos that we get is appropriate and of the highest order is been a challenge, which I think the organizing team has met very nicely. The next challenge was, of course, to get them evaluated. And there, it was impressive how the network of teachers in and around Pune was then made part of this exercise to act as the judges for judging these projects. And I think that's again it just embodies this spirit of inclusiveness that we could involve the school teachers and others to be part of this exercise. I think again is a very big achievement of just spreading this interest and enthusiasm for science all around. And then, of course, was the thing about further enhancements that have been made. So now there is, viewer participation, as was explained in evaluating proposals. So there is a way in which viewers can now be part of this, and that just adds to the viewership. It adds to the interest of the general population to look at these videos, which I have to say, some of them are extremely good, very well done. And again, I think people learned in COVID how to present yourself online via videos rather than in-person presentations. And I think all of this has worked out very well. And going forward, I see a very bright future for this avenue of growing interest in science in a wider population. The world has no boundaries. So the analogy that comes to my mind, that's why I started with the 30 kilometers of GMRT, that as you grow, the GMRT is an instrument that collects the signals from 30 antennas and combines them to make high-resolution images with which scientists do science. And Divya Oberoi explained about what is unique about the GMRT. But you can, of course, expand the array and start collecting data from larger and larger distances to make better and better images. And that's in the way our engagement with the science community in the country has grown beyond the 30-kilometer boundary of GMRT, reaching out to different parts of the country. And interferometry tells you that the land borders are not a limitation. You can combine data from antennas in India and in the US and the UAE to make even better quality images of the sky. And I think in that same way, we have grown from normal interferometry to what I call very long baseline interferometry. And of course, again, in semi-joking manner, I have the challenge to Nilesh ji and to Solanki that interferometry can be done with antennas in space also with Earth. And we can see how we take this movement to space at some date. All right. With that light note, I will end. And I wish the very best for the rest of this process, which will follow after the inauguration today. Thank you.
Thank you. Thank you very much, sir. Thank you very much. So, before we request our chief guest, so we have couple of teachers who are involved in our evaluation process, and they have been continuously participants for our International Science Day for last 2 years and National Science Day for last 5 years. So I request Khodad sir to just say a few words. Khodad sir. Khodad sir, am I audible to you? Yes. You are, please unmute, Khodad sir, unmute. Khodad sir, you are muted. Yes, please.
हॅलो
Yeah, please continue, sir.
ऐकायला येतंय ना सर?
Yes, please continue.
हा, उपस्थित सर्व मान्यवरांचे मी आभार मानतो. आता ही जी ऍक्टिव्हिटी डॉक्टर सोळंकी साहेब आणि निलेश यांनी जे काही श्रेय घेतले त्याला खरोखर माझा सलाम आहे. सातत्याने ते विद्यार्थ्यांपर्यंत पोहोचतायत, विद्यार्थ्यांना संधी देत आहेत आणि आत्ता ह्या पद्धतीने प्रथम महाराष्ट्रामध्ये, नंतर मग संपूर्ण भारतातील काही राज्यांमध्ये आत्ताच माहिती मिळाली की जवळजवळ 13 स्टेटनी यात पार्टिसिपेट घेतले आहे आणि त्याचबरोबर इंटरनॅशनल लेवलला देखील काही एंट्री आलेल्या आहेत. आणि याचं सर्व श्रेय डॉक्टर सोळंकी आणि चडवेलकर सर, निलेश सर यांना जाते. आम्ही परीक्षक म्हणून यामध्ये जास्तीत जास्त व्हिडिओ ऐकून कोणत्या पद्धतीने त्यांनी काम केलेलं आहे आणि खरोखर त्याच्यामध्ये त्यांचं इन्व्हॉल्वमेंट काय आहे ह्याच्याकडे आम्ही लक्ष देतो आणि त्याच्यावरून आम्ही इव्हॅल्युएशन करतोय. सोळंकी साहेबांना माझी विनंती आहे का यातून जे विद्यार्थी पुढे येतील किंवा ज्यांना आपण बक्षीसपात्र किंवा निवड केली जाईल त्यांच्यासाठी आपल्याला एखाद आठवड्यासाठी नारायणगावला काय आपल्याला सेमिनार अरेंज करता येईल का, जेणेकरून त्यांना ॲक्च्युली GMRTचं काम कसं चालतंय आणि त्याच्यामध्ये या विषयावरती त्यांना चांगल्या रीतीने माहिती मिळाली तर आपल्याला ॲस्ट्रोफिजिक्ससाठी काही विद्यार्थी नक्कीच अभ्यासाला पुढे जातील असं वाटते. परत एकदा सगळ्यांना धन्यवाद देतो आणि या कार्यक्रमाला माझ्या मनापासून शुभेच्छा.
Thank you, Khodad sir. Khodad sir spoke in a local language here because that is the normally here. But then what he mean was that this is actually the efforts of NCRA and Indian Institute of Knowledge has proven fruitful to many college and school students and children to participate remotely. So thank you, Khodad sir. I think we have another teacher just for a minute. Rathod sir, if you can speak either in Hindi or English, that will be great. So that our audience today is not only from Maharashtra, they are from outside of Maharashtra also. Rathod sir. Rathod sir. Okay, I think it's not there.
सर आवाज आ रही है सर?
हाँ, आवाज आ रही है, आप यस.
हाँ जी, सभी मान्यवरों से मेरा नमस्ते. पिछले जब से GMRT ने जो एग्जीबिशन शुरू किया है तब से मुझे मौका मिला है यहाँ पर इवोल्यूशन के लिए, तो इसलिए GMRT और सोलंकी सर, इनका मैं शुक्रगुजार हूँ और उम्मीद करता हूँ इस साल भी जो प्रोजेक्ट है उसमें से जो इवोल्यूशन के बाद अच्छे प्रोजेक्ट आगे आएंगे और बच्चों को बच्चे जो है वो प्रोत्साहित होंगे और अगले साल इससे ज्यादा बच्चे इस एग्जीबिशन में पार्टिसिपेट होंगे और सभी बच्चों को शुभकामनाएं देता हूं और धन्यवाद।
थैंक यू फॉर सभी लोगों के लिए जो हमारे चीफ गेस्ट है, जो एनसीआरए में बहुत परिचित है, लेकिन मैं आप सभी के लोगों के लिए उनका परिचय देना चाहूंगा। आज के जो हमारे चीफ गेस्ट है प्रोफेसर दीपांकर बैनर्जी, जो वाइस चांसलर है इंडियन इंस्टीट्यूट ऑफ स्पेस साइंस एंड टेक्नोलॉजी तिरुवनंतपुरम, केरला। तो उन्होंने जो बैचलर्स की डिग्री की है वो सेंट जेवियर्स कॉलेज कोलकाता से है, और मास्टर्स डिग्री भी थ्योरेटिकल फिजिक्स में यूनिवर्सिटी ऑफ कोलकाता में पाई है। He has obtained his PhD from Indian Institute of Astrophysics, Bangalore, and completed couple of postdoctoral fellows, and then he held a senior professor in the same institute where he completed his PhD, Indian Institute of Astrophysics. After his experience and all this thing, he became the director of Aryabhatta Research Institute of Observational Sciences in Nainital, and afterwards he is now currently having the post of Vice Chancellor, Director of Indian Institute of Science and Technology, Thiruvananthapuram. Dr. Banerjee's area of interest is the sun and solar atmosphere. His work involves theoretical and numerical modeling using data from ground and space-based instruments. His work has enriched our understanding of the sun and its impact on space weather. He is also the co-chair of Science Working Group of Aditya Mission. Aditya is the first dedicated Indian mission to study the sun, launched by ISRO on 2nd September 23. He is also involved with NASA's Punch mission. He is fellow of the Indian Academy of Sciences, National Science Academy, Royal Astronomical Society, and currently, I think, held the president of the Astronomical Society of India. Dr. Banerjee has more than 150 peer-reviewed publications and around 4,000 citations in international journals. He has either currently guiding the PhD students or completed around 20 plus students in his career. Apart from his scientific career, Dr. Banerjee has interest in various other activities. He is trained in Hindustani vocal and also plays a very significant part in Bengali theatre group whenever it is getting opportunities. So, of course, his CV and biodata is much more than I can take time, but for this current things, I could speak about him this thing. And with this, I will request Professor Banerjee to first inaugurate this GMRT Online Science Day by following the procedure, and afterwards deliver an inaugural talk.
Unmute myself. So I'm audible clearly?
Yes.
Yes.
Yeah, and you can see the screen also now, right?
Yes.
Okay. So thank you very much for this opportunity. I'm very excited. So many young students are online. So I will try my best to motivate some of you towards some science projects, particularly our own Aditya mission. So before I go, first I will take this responsibility of opening the exhibition. So should I click to go to the website?
Yes.
Okay, so that's the launch of virtual exhibition. Should I browse through any other link?
No, that is there will be
Or we'll probably expect the students to go through the website and see other there are different icons I could see, tabs here, which is exhibition. So there are, I think, further descriptions here, and then participants group.
So you can play one of the videos in group 1.
View project group 1, okay. So these are our videos?
Yes.
Okay. Okay, I think this needed rotation.
Okay,
Yes,
there may be
please,
some
please,
issue, but now you
loading.
can.
Yeah, so what I understand is there are very, very interesting, hundreds of projects. So all the best for the students for their participation and their selection. Yeah, here it is now. The audio is coming here. So I will also try to go through some of this, and I'm sure the students will enjoy.
Yes, sir. Now you can start.
So
Request you
let
to
me
deliver your
start my
inaugural speech.
presentation. Just to confirm. I hope my screen is fully visible now.
Yes.
Okay, okay. So again, thank you very much for this opportunity. My good old friend, Professor Ashwant, and then Ishwar, Divya, we were almost started from our student life. So students, you will see that, as Divya was pointing it out, that whatever we do, we are always excited and we are enjoying our time. And that can be only done when we are in the present continuous, time. So as Divya was pointing it out, of course, when you first learn science, you have to know the basics, the history. But now as time progresses, we have to, live with the progression of the science, and we have to always be innovative and so on. So today, what I thought, I will take you through a journey towards our sun with our own mission from ISRO, which is named as Aditya L1. So this will be a bit of a flavor. And this cartoon, which it shows here, that, here we are in the Earth planet, but we are actually protected by Earth's magnetic field. You see, this is sun here, so don't bother about the internal properties or whatever detail is showing. But essentially, there are huge explosions happens in the solar atmosphere, and continuously, particles and material and then magnetic field and all that comes from the sun. But the near Earth, there is a magnetic field shielding is there. So they are actually protecting, these magnetic field is protecting us. So all our, life is possible on Earth because of these magnetic structure. But as you see here, the magnetic structure is quite disturbed because of these, this continuous material which is coming from the sun, which we call solar wind. And sometimes there are huge explosions. I will explain those. But the problem now is that we are now dependent too much on the space assets. And as you see, this particular gentleman is roaming around in space, but he or she is going to be exposed to these radiations and the particles which is coming from the sun. So we need to really be able to predict when such huge explosions will come, from the sun and so on. We are planning to make our colony in moon and so on. So then Earth's magnetic field is not there, and then we are completely exposed to this, these particles which is coming from the sun. So that's the subject which I will talk about. But before I do that, I thought, I will also give you a very quick glimpse of the institute where I am now talking from. The name of the institute is called Indian Institute of Space Science and Technology. This is primarily a Department of Space institute. So our graduate students, our postgraduate students, they go to our ISRO's own program. So we have been really proud of 1,400 plus engineering graduates who are now scientists at different ISRO centers within the country. So the institute was instituted for this purpose of training and R&D development and innovation in the space sector. And we do really have, we are privileged to have really, really highly sophisticated labs. And you could see here, the students are actually building this kind of small payload. We also have our, in the top of the mountain, certain observatory and so on. So this is an institute where, just very briefly, I understand there are students from school, college, and different levels. So just for the sake of your career, guidance, if you want to know more about it, please do write to me. I will be happy to answer. You can also visit our website and so on. So as you see here, I will just show you that different BTech program which we run here in aerospace engineering, in electronics and communication, in computer science, engineering physics, and then we have the dual degree program in these kind of space sciences domain as well. We have also 16 master's degree program, and we have 400 plus PhD students. So it's a very dedicated, institution for space science and technology both. And this is our almost like always a best practice lab. We call it Small Spacecraft Systems and Payload Center. Essentially, the beauty of this is that our undergraduate students, they build this payload. And since we are part of ISRO system, every 6 months we get a free ride to go to space through one of the satellites. And these instruments which are built by students, they go to space. And we also have our own ground stations within the same campus. So they build this payload, scientific payload. They fly through our own spacecraft, and they can also talk to the instruments. We sometimes I tell them that they build their toys, and they can also communicate with the toys with our own ground station. After dinner, they just walk down to the control station, and then look at the data what is collected by this scientific instrument. So this institute is quite unique, and we call it experiential learning. And I'm sure some of you, if you have also visited GMRT, you will see that how the scientists and engineers are working together for the exploration of the universe. So here, of course, we work in different domains, and particularly I only work on the sun. So I will again now come to my own domain, primarily our nearest star, the sun. So what you see here is this is the image of the sun taken from, again, a satellite from one of the NASA satellites, and looking at the very outer atmosphere of the sun. And you can see here, there are a lot of areas where the sun looks very bright. And of course, sun rotates about its own axis and so on. And there are, of course, internal properties of the sun. Right in the core of the sun, there is a nuclear reaction which is taking place, and there actually all the energy of the star is being generated there through a hydrogen getting converted to helium and so on. So that's the source of energy for any star, for that matter. So so that's the interior part. I will not talk much about the interior today. I will be talking about the atmosphere, and if change is happening in the atmosphere, how it impacts us in the near Earth environment and so on. But before you do any science, often we have to look back to the history. In fact, Divya was also pointing it out that it is important to look at the history where the things got originated. In fact, Professor Ishwar Chandra also said that sometimes we take things for granted. We don't know, 400, 500 years back, how the scientists actually worked in their limited, abilities and limited, infrastructural facilities, and what kind of discoveries they had made. So this is a gentleman. His name is Galileo Galilei, a philosopher and one of the greatest scientists of all times. And thus that time the telescope was invented, just few years down the line. And he looked at the sun, and what you see here is essentially his hand drawing. Every day he was looking at the solar image in his in his paper. He was projecting that solar image on a paper, and he was marking where these small little spots are there. And he realized when he has looking at subsequent images on subsequent days, that actually sun, this particular spot, it is moving to the next location, and then to the next location and next location. This is only possible if sun is actually rotating about its own axis. And these spots, what is marked here by pencil by Galileo, only later on it was known, several hundred years later on, that these are nothing but regions of strong magnetic field. Galileo didn't know that this was magnetic field. And of course, we know and we study them in greater detail. And these dark spots on the sun, on the solar surface, are called the sunspots. And that was, you can imagine more than 400 years back. Now we have better telescopes. We can look at these dark spots in a much, greater detail with a sort of, larger telescope. And as you will clearly see that these dark spots are revealing much more detailed structure. And then these regions are called, these are dark because they are actually absorbing certain amount of energy which is coming from the below, and they are magnetic in nature. So that's these particular dark sunspot regions are the locations where there is a presence of strong magnetic field. Now, these magnetic fields are also very dynamic, and these structures do not live for very long. They become, they can be twisted and so on. So how these dark spots are coming? So these dark spots are magnetic structures. They are coming actually from below the solar interior. So this is the surface. So this animation shows how these, these kind of tubes, we call them flux tubes. And these flux tubes are nothing but millions of magnetic field lines. If some of you have done some experiment with the bar magnet in your school lab, you will see that how the bar magnet, a bar magnet has a north pole and south pole, and you sprinkle some iron fillings, it takes a little shape, we call them lines of force or field lines. So these particular iron fillings, they follow that magnetic field lines. So here also, these are like a magnetic tube. They're almost like rubber tube. If you put a rubber tube inside a bucket of water, what happens? The rubber tube starts floating. So here also, these magnetic tubes are lighter than the surrounding, so they float. And when they float, they come up. And as this animation again shows, that they're coming from the underneath the surface of the sun. So here they come. When they penetrate the surface, here you will find one polarity, and the other side is another polarity, because magnetic field always have two polarities. Magnetic monopole doesn't exist. But what is happening here? These tubes, you see, they're getting twisted, and after certain twist and all that, there was an explosion. We call that process called reconnection, and then whatever material was there, it got thrown out. If I just play the last part of this movie again, you will see here that there was this reconnection, and that whatever huge amount of material was there inside the tube is thrown into the outer atmosphere. So here again, the same movie is shown from another. This is the real observation from one of the NASA satellites. And here you see these magnetic tubes again. We call them, sunspots are there underneath. We call them, active regions, because they're much brighter and active as compared to the surrounding region. And as you see here, these active regions are evolving with time. And after certain time, they become unstable. And when they become unstable, there is a huge explosion here, and huge amount of material, can be flowing into the interplanetary space. And these kind of environment are for physicists like us are very ideal laboratory. And whether you belong to atomic physics community, you belong to particle physics, nuclear physics, you name it. If you are interested, I can give you a number of projects on each of these areas into this. So that is the area which I will focus on today. But now, as I showed, that those huge ejecta, we call coronal mass ejection, when they're traveling to the interplanetary space, now we have very sophisticated NASA missions called Parker Solar Probe, and that is moving much closer to the sun. It is really traveled much longer distance toward the sun. They have actually gone so close to the sun, they can't look directly to the sun because they will be completely burnt out. So they are looking away from the sun, and when such an explosion happens, they are tracking the trajectory of these huge ejecta. We call these also solar storm, because these solar storms, you can imagine, if you are trying to take a satellite through these solar storms, it is very hard for the satellite to survive. Of course, Parker has been designed to be protected from these particles and so on, but it costed some 100 times more than a normal satellite. So that's the domain which we are talking about. And so when these CMEs, these coronal mass ejections comes to the Earth, we are also, of course, have numerical simulations in the physics, equations. If you put it in a model, you will see how it interacts with the Earth's magnetosphere. So as I said, that we are very lucky that we are here in Earth. Earth also has its magnetic field, and these are the same magnetic field lines which I was talking about. So normally you will find very symmetric this kind of magnetic field lines. But when a storm comes, it pushes these magnetic field lines, and you get also certain phenomena. We call that here you see when this huge CME came, it completely disturbed the magnetic field lines, and the storm interacts with Earth's magnetic field, and there are other effects also which we study. So these kind of storms are really making havoc to our space assets, and this particular area is called space weather. If you recall, when we were actually young, we used to go to the seaside for holiday, and I remember in the Puri, the fisherman will first thing will do in the morning is listen to the radio. Is it safe to go to the sea to do the fishing and so on? So that's our weather forecast, right? Now, what is happening? A satellite company, or Mr. X, if he wants to go to space, he has to call some of us and find out that whether there is a solar storm likely to happen. If there is a solar storm, then the satellites are going to be in problem. So it's just not only satellites. Our communication systems, they are all getting affected by these kind of solar storms coming. Of course, astronauts, we are also planning for our own space stations. And as you can imagine, if somebody is just coming out of the space station to doing some activity, he or she is going to be exposed by these solar storms. And then, we need to worry about their safety and so on. The satellites, when they're launched, normally we calculate that the trajectory of the satellite based on some atmosphere model, Earth's atmosphere, how the density is varying with different height, what sort of temperature and so on. But now you can imagine that when such a solar storm happens, that background state of the density, temperature, and all that other profile can get drastically changed. And that's what actually do happen. And then the satellite trajectory gets also completely, disturbed. And we call them as atmospheric drag. Here you see here we have showed particularly for satellite which are in the low Earth orbit, they experience different kind of atmospheric drag in the presence of solar storm. So that means their path has to be corrected by using certain certain extra fuel and so on. That has to be done. Of course, you can also think about our navigation system disruption. Our GPS, they are completely determined by the positions of the satellites. We need multiple satellites to have a precise GPS location. If one satellite gets disturbed or damaged, then our GPS locations will be disturbed. We also have lots of our radio propagation, which is completely dependent of ionospheric conditions. So when such a storm happens, the ionosphere also gets changed. So our communications will be disturbed. We also have, lots of electric grid, systems, these transformers and this, huge power line systems. When such energetic particles with the form of the storm is arriving, they will interact with these power grid system. They will create induced currents, and that will give you a complete blackout. So the transformers can get completely burnt as well. And it does happen. So all these makes it very, very important to really be able to study the space weather. So that's one kind of variability which we talk about, really transient variability. And there is another variability which we also now know. What I showed about this sunspot. So what is plotted here is yearly sunspot number for last 400 years. And what you see here, that sunspot number sometimes it is more and sometimes it is very, very less. So we call them, these are called solar maxima. So whether there are sunspots or absence of sunspot, that determines whether the sun is active or not active. So we measure the solar activity, we call it solar magnetic activity, by recording the number of sunspots on the surface of the sun. So here historically you see that sometimes there have been many sunspots. There are periods over which there are only very few sunspots, and typically these periodicities are 11 years. But what you see here is no two cycles actually look same. So this is called sunspot solar cycle, and none of these are actually exactly the same. So that means, it is not a very simple, equation which you can solve and then you get a solution that, the periodicity and amplitude and so on. Much more complications are there. Even more, things to be observed is between 1650 and 1700, there were hardly any sunspots recorded, almost for 15 years, because, telescope was already, discovered almost 50 years prior to that. So it is very unlikely that, we were not observing the sun at all. So there are records that the Chinese were very, very regularly, recording the sunspots and, so on. So this absence of sunspot is still, we do not understand very well. What was the effect of that? We call it, Maunder was the first scientist who measured this. This is the period where Earth was extremely cold. We actually now correspond those as mini ice age. This is a picture, this is a drawing in Europe. The river was frozen, Volga River was frozen for 30-40 years. There are records that in England, the Thames River, people were doing the, Christmas fair on the Thames River itself because the river was frozen. So people could just, make parties on those kind of period, even in 1800, which is again another minima called Dalton minima. So there are historical now evidences that when sunspot numbers were less, that means sun was less magnetically active, it was directly impacting our climate. So this is again another very important area we study by looking at the sun or solar data for several hundreds of years, or even some proxies even prior to that. We call it space climate, because you can imagine that we are here and our life is possible only because sun is there appropriate distances away. And we always think that sun is emitting the same radiation and so on. But there is minute variations of the sunspot's total or sun's total radiation. And that depends on whether the sun is magnetically active or magnetically weak. So it is very important to now monitor the sun in a really, really daily basis for centuries of years to understand. And as you now have understood that, the Western world was very much aware about the importance of the sun and its radiation and particle. So there are so many satellites you could see just for study of the sun and sun-earth system. We call it sun-earth system because Earth is very much influenced by the presence of the sun and its radiation and the particles and so on. So to study this, we had so many satellites from European Space Agency, NASA, and Japanese agency, and so on. But we started our business a little later. But nonetheless, we have started with a bang. Because as you can see here, this is our mission called Aditya. We have gone very, very, reasonably far distance away from the Earth, 1.5 million kilometers away. This is a location called Lagrange 1. This is a pretty nice, a location to have a continuous look towards the sun. And we are really, really privileged that at this stage from our own, space agency, we have been able to build lots of instruments to look at the sun. So this is the several instruments which are built. I will not go into too much of details because also for a bit of a lack of time. But again, I'm just showcasing few examples of the instruments what we have. And where, we are working on this, we are observing the sun continuously 24/7. Lots of terabytes of data are being, being recorded and received at our Bangalore ground station, and which is distributed globally also freely to the global community. So it's a huge, huge opportunity for showcase us. So we have several, remote sensing, and remote sensing means, we look towards the sun remotely and record its image or spectral properties or the amount of X-ray flux and all that is coming and so on. So I think, since we are slightly running late, I will sort of, skip few slides and showcase where we are. And maybe I will just show a few examples of this events which we are recording from our own Aditya's payloads. So this is one of the payload which we are looking at. You can see part of the sun here in near ultraviolet. And when such a huge explosion happens, we are able to track this object very close to the sun. So that's the difference. If you could, compare the earlier movies which I was showing and this one, you will see very clearly we are focusing on much closer to the sun and to the lower atmosphere of the sun rather than the higher atmosphere of the sun. So the higher atmosphere of the sun is called the corona. So here we are looking at, we call it chromosphere, about 1,000 to 2,000 kilometer height from the surface. And we are trying to identify the source where these explosions are coming and so on. So these are very, very new results which are now already been reported with the highest impact journals. Last year, it was quite actually even the year before now, in May 2024, in 1 week, we could detect that huge X-ray fluxes. So what is plotted here is X-ray flux with time. And we call these huge changes in the flux, it's called X class. These are the highest class of flares. And we were so lucky to record so many, flares. The flares are these events when such explosion happens on the solar atmosphere. We call them reconnection event, and that gives rise to a huge increase in the X-ray flux. And these X-ray fluxes are recorded at Lagrange 1 point by these by these kind of instruments. And that is a slightly low energy X-ray spectrometer what we have. This is a high energy X-ray spectrometer. The same time we have detected so many X-class flares. So these flares are happening once in a while in the sun. Of course, this was quite a unique event that 1 week we had so many flares, because also the fact was the sun was very active during that period. So now we have crossed that solar maxima activity phase. We are coming down to its activity level. This is again another instrument which also recorded the magnetic field of this huge storm which came from the sun. So what earlier result what I showed was remotely, and this is called in situ. Means you are at a Lagrange 1.5 million kilometer away from Earth, but we are still very large distance, 99% distance away from the sun. So when such a magnetic storm comes, before it reaches Earth, it has to pass through the Lagrange 1 point. And there, if we have certain instruments which has a capability of measuring the magnetic field or its electron properties or charge properties and so on. So here what I'm showing is actually the magnetic properties of these storm. There was a huge magnetic field which was recorded the same period of this May week which I was showing. So this allows us to study the impact of these storms when it will hit any satellite and so on. We also have an instrument called coronagraph, again, which blocks the solar disk light, and then it allows you to look at it again very close to the sun. So these are beautiful solar structures which you saw earlier. So here you see these structures are very, very nicely be captured by our coronagraph instrument, and we are studying these properties of these loop structures, what kind of temperature they have, what kind of density they have, and when they become unstable and so on. So these are really very, very nice ongoing work. I thought I will just give you a very quick flavor. Then I will briefly mention, because we are also participating in this experiment. This is a very unique experiment called PROBA-3 from European Space Agency. What it did was there were two satellites. They were together when they were injected in space, and they were injected from our own space platform with the PSLV launch. PSLV is our main launch, which also was used for Aditya's launch. And here, for this PROBA mission from European Space Agency, the Europeans came to us and asked PSLV to be used for their launch. So this is again a very, very proud moment for that. And I thought I will share for the youngsters that globally also now our activities are being recognized, and we have been probably been now taken seriously now. So here what it is happening is beautifully, this is a combination of, we call it a formation flying experiment. One satellite is blocking the solar disk, and the second satellite is in the shadow of these. So what it does is, in the shadow, if you are there, if you can think about this total solar eclipse situation, when the moon blocks the solar disk light, we get total solar eclipse on the Earth some portion. So here exactly that is what they're trying to maintain. These two satellites, this satellite is called occulter, this is called the coronagraph spacecraft. So you could see here that this shadow is forming here, and they are able to see the corona. So the corona of the sun is only visible when you block the solar disk. This can be artificially blocked, or during the total solar eclipse only we can study the corona. So here what the beauty is, they are in the formation flying in space. You can think about it with several close to 1,000 kilometers per second. They are moving, and then they are keeping a separation of 150 meter, but the accuracy with which they have to keep this is 10 millimeter. So the accuracy with which they have to keep their position with respect to the occulter satellite is 10 millimeter. And autonomously, they are maintaining it in space. There is no ground command which is allowing them to do this. So there are some laser techniques which they are using. Two satellites are talking to each other with laser holography and so on. So I'm not getting into that technical details, but this is a technologically, a huge challenging task. So these are called technology demonstration mission, and we are participating toward that. And this is the kind of proba images which is available now. So we are working very closely with these people. You can see very beautiful green, corona. And I showed you our coronagraph images also, the green corona. So we are working closely now for understanding these regions. So what we are doing is that it is important to go beyond your boundaries. And I think today in the earlier session also, we were discussing that science has no boundary. And to enhance the scientific understanding and our scientific temper, it is very important to connect with the international community. So here, this is a very, very clear example that this is our Aditya mission, how closely we are actually working with our colleagues in Europe and America to get a better understanding of this thing. And we are doing this particular exercise, and I thought, I will share how important it is to go beyond your, own boundaries. There is again another huge opportunity which has come. It has never happened in our lifetime, that in our union budget, that to boost the leadership in mega science, there was an announcement to promote astrophysics and astronomy through immersive learning experiences. So 4 major projects have been approved by our government. I think we are in a golden age of astronomical observational domain, and the idea is that we will have a very high aperture large optical near infrared telescope from our already existing observatory in Hanle. This is in the Ladakh region. And there is a beautiful lake called Pangong Lake. And in front of that Pangong Lake, we are planning for, setting up a national large solar telescope. This will be also one of the, biggest such class telescopes. So that's the telescope again. This is the beautiful lake. Some of you might remember or have seen this beautiful lake picture from famous Three Idiot movie. And we are so fortunate to set up our, lab here, and we are planning to set up this huge telescope out there. So I think the time is really very, very fortunate, and it's all for the younger generation. So I hope, I've been able to give you some flavor about why, I look at the sun and get involved with solar observations from ground and space platform. This is a picture taken from my mobile phone from the earlier, my working place at Nainital. It's actually another place called Devasthal, which is near Nainital. We have an observatory, and you could see the beautiful Himalayas from there. So the point is that you do science, it allows you to enjoy your life and also to travel to wonderful places across the globe. And I hope some of you will feel that, this is a worth, career to pursue. Thank you for your attention.
Thank you, sir. Thank you very much. And as you rightly said, it's the time, and we are, of course, at the end of the program today. Sir, with a very, let me just express thanks on behalf of NCRA to you because you agreed really in a short notice and agreed to be the chief guest of this function. And you delivered a very wonderful talk today and enlighten our students and college students community about your research area and son everything. So thank you very much for gracing this occasion. Thank you very much. Along with this, I thank you, Professor Yashwant Gupta, Center Director, Professor Ishwar Chandra, and Professor Divya Robai, and all our NCRA colleagues supporting this event very proactively for all the things, and respected teachers who joined online and who will be there on these things, that they are being helping all our evaluation process and spreading this event across the country and outside. Thank you very much, all teachers and students, teachers, and all these things participated through online. I really want to thank each and every one of you. Thank you, Meshram, for making these arrangements and everything working very so smoothly. Thank you, computer group, electrical team, and everyone who is making this event successful. Thank you very much. And with the permission, Professor Yashwant Gupta, I would clearly like to close this event. I'm waiting for him.
Yes, no, thanks. I think it was a very nice event, and thanks, Dipankar, for your words and for a very nice talk. I think we can close now.
So with this, if whoever is there online, can I request you to keep your camera on? So we'll just take online photograph of everyone. Ekad sir.
Now Nilesh is there. He's traveling, but he has joined.
Yes, Nilesh ji has
Hello.
joined.
Hello, sir. Very nice program. Hello, sir. Namaste.
Namaste, namaste.
Very nice activity.
Thank you, Ekad sir. Patan sir, thank you. Okay, so thank you everyone. Thank you very much. With this, we close our program. Thank you everybody. Nilesh ji, thank you.
Okay.
Thank you, sir. Thank you.
Yeah.
Okay, then. Thank you.
Yes, sir.
Bye-bye.
त्याला कोरडे सर कन्या काय म्हणते? नात काय म्हणते?
तिला ऍस्ट्रोनॉट व्हायचंय म्हणून मी तिला ते दाखवत होतो.
छान छान. म्हणून त्याचं टॉक सुरेख होतं. थँक्यू. बाय बाय. राठोड सर बाय.